So at this time, we have learned everything that we need to learn about transformations. And so what we need to do is we need to actually utilize that information. So let's kind of recap everything at this point. There's a lot of information here. So this here, y equals a times f of c times x plus h minus k. Any one of these letters, a, c, h, and k, can transform our graph. The f of x should stay there. That's our consistent, that's our basic graph. And so we need to figure out, right, if something's given to you in this format, what do all of these letters mean? And so I've tried to separate it in two ways. And if you partner these two ways up, it should tell you exactly how the transformation should be. Okay, if the operation is multiplication or division, and the way that we would see a division is if it's multiplied by a fraction, then the graph is stretched or shrunk. If it is multiplied by a negative, then the graph is reflected. If it is added or subtracted, then the graph is shifted. And we can see that I've tried to summarize that by which letters is happening there. So A and C is all the multiplication, and then H and K is all the addition and subtraction. All right, so that tells us how it's going to be transformed, but now we need to know in what direction. So something that you've heard me say consistently, if it's on the outside of the function, then it's a vertical transformation. And so those are the letters A and K. So notice those are on the outside of that set here, my A and my K. If we are on the inside of this set of parentheses, like C and H, that's going to happen in a horizontal format. And the thing about in the inside is it's always going to happen backwards of what you think it should do. So if it's added, that means we're actually going to subtract it. If it's multiplied, that actually means we're going to divide it. So the inside operations are always backwards. Okay, so let's work a couple of examples here. So I skipped example 3 back in the reflection one, but I think this is a perfect time to come back and recap it. So this is where you pause the video and see if you can do this one all on your own. Lots of transformations, but I bet you can handle it. Okay, so I'm going to tell you probably the mistakes that you made, and then I'm going to explain to you why that mistake is what it is. So if I take this function exactly the way it is, I'm going to assume that this negative on the inside is going to make it reflect horizontally or reflect over the y-axis. This positive 1 on the inside is going to make it shift horizontally. And so if you think backwards, if it's a positive, I will actually shift it left 1 unit. And then this negative 3 on the outside is a vertical. It's subtraction, so it's shift. So it's going to be shifting down 3 units. Well, 2 of these 3 things are correct, but the one that's incorrect is this one here. The problem is anytime we have a multiplication and a addition or subtraction on the inside, we have to think back to our PEMDAS rules. Multiplication has to happen before our addition and subtraction. So we have to think about this in terms of multiplication first and then addition second. So anytime you have both of those operations on the inside, you must factor out what your multiplication term is first, and then that will tell us the correct corresponding shift from there. So this is not the proper way to view this function when we're looking at transformations. What we want to do is we want to factor out that negative. So the better way to see this is a negative h minus 1 and then the minus 3 on the outside. And now I have it in terms of multiplication before addition or subtraction. So now this negative still does the same thing. So this negative still reflects it over the y-axis. My minus 3 on the outside still does the same thing. It shifts it down 3 units. But now, notice on the inside I have a subtraction of 1. So instead of shifting left 1 unit, I need to shift it right 1 unit. And so now everything after that is good to go. Okay, and I skipped the basic part, but I think we all know that the basic function of this is just y equals square root of x. And so the shape of square root of x looks like this. And now let's take all of these points and let's do all the transformation for it. So if I take my first point and I reflect it over the y-axis, it's still going to be there. I shift it right 1 unit, and then I shift it down 3 units. So that's where my new point is going to go. If I take my second point here of 1, 1, if I reflect it over the y-axis, that puts me over here, and then right 1 unit, and then down 3 units. So that puts me right there. Okay. And then my other key point I've identified, if I reflect it over the y-axis, that puts me over here. Right 1 unit, down 3 units, puts me right there. And so now I can see my transformed graph looks like this one here. And we can talk about now x-intercepts, y-intercepts, domain, and range if we want to figure out that value. So we can see very clearly the y-intercept. Okay, it is at 0, -2. My x-intercept, I don't specifically see right here, but if I were to graph this graph out farther and farther, I could see where it intercepts out there. So I'm not going to worry about that now, but that is a key element to focus on at a particular time. My domain is the possible x values. This graph goes forever to the left, and it stops here at the right at my x value of +1. In my range, my graph starts at the y value of -3. It does not go below -3, and then it goes up forever, so up infinity. And this one is actually part of the graph, so it should have been a bracket instead. And so we have everything done with this function that we want to. So the key thing to this is anytime you have something on the inside that is both multiplied and added, you must factor out your multiplication first because it will change your addition thing from there on out. Okay, let's move on to the next example. H of x is equal to 1/3 x cubed plus 1. Pause the video, work it on your own. Okay, so my basic function is x cubed. Transformation. Everything is on the outside because I don't have anything inside the cube motion. So I have the 1/3, it's on the outside, it's multiplied, so that means I'm actually going to shrink it by 3 units. I should say shrink vertically by 3 units. And the +1 means I'm going to shift up 1 unit. Okay, so if we can recall what our basic graph looks like, something like this. And now I need to do all of this math with it. Okay, so I'm going to only adjust my y values. So my y values, I multiply by 1/3 and I add 1. So 0 multiplied by 1/3 is still 0, but then I shift it up 1 unit. 1, if I multiply it by 1/3, that gives me 1/3, but then I shift it up a unit, so that goes right here. If I had my point up here identified at 8, if I multiply it by 1/3, that gives me 8/3, or 8/3 is the same as 2 2/3. And then if I shift it up a unit, that gives me 3 2/3, right? 8/3 is the same thing as 2 2/3. These ones here, -1, if I multiply it by 3, that gives me -1/3, shift up a unit. And -8 gives me -2 2/3 shift up a unit. And so this gives me my graph, oops, missed one, graph here. So the shift is pretty obvious, but then also notice I smushed it vertically. I smushed it like this. And you can always double check this by graphing it on the graphing calculator. Okay, so I think we've seen enough examples of this type. Now it's time to tweak it and to give you kind of a different idea of example. So this one doesn't give you a basic graph at all. It just gives you a point. And it just asks you to transform that one particular point. And so I have the point -8, and I'm going to transform it 3 different ways. And so pause the video and see if you can figure out how each of these will be transformed. Okay, in part A, we have a subtraction, so that means I shift it. It's on the inside, that means I shift it horizontally. It's negative, so that means I shift it right. So I need to take my point -8, and I need to shift it right 3 units. That means I take my x value of -8 and I add 3 units to it. So my new point would be -5, 5. And you are always more than welcome to graph these to see if it does what you actually think it should do. In part B, I have a multiplication of 1/2. Multiplication means stretching or shrinking. It's on the outside, so that's a vertical motion. That means it's going to affect my y values. So I take my y values times 1/2. In this case, my y value is 5. If I take it times 1/2, that gives me 5 halves, or maybe 2 and 1/2 if you need to think about it that way. My x value was not adjusted. Notice I didn't have anything on the inside here. So my final point is the same x value and then my smushed y value. Part C is a multiplication, so it's a stretching or shrinking. It's on the inside, so I do it horizontally or with my x values. So that means you would originally think I'd multiply it by 4, but actually divide it by 4. So I take my x value of -8 and I divide it by 4. So my new point is at -2, 5. And so there is how we treat each of these points. If you think about it, we were doing the same thing here, right? We just weren't writing it out. I was taking this value and I was multiplying it by 1/3 and then I added 1. That's the exact same thing that we're doing here. It's just focusing on one point rather than a whole graph. I'm going to stop this video here. In the next video, I have a different type of examples, a couple of them. So we'll come back and we'll finish those up.